Greetings, I'm Squared, and today we're going to talk about compound inequalities. Sorry, the lights just went out and then came back on. Compound inequalities are ones that have ands or ors. So they kind of combine two different inequalities into one graph. So it's a combination, that's we call it compound. So it's two or more. We're going to just deal with the two usually when we start off. So an or means that it can be either, to make it true, it could either be this or this. So in this particular case, it could be either be less than 3, so you see the open circle going to the left, that's less than 3, or it could be greater than 5, so you see the the open circle at 5 and going to the right. So that's what or can be. So what it can't be is what's in between here. An and means that both things have to be true at the same time. So this one is an or, both of them can't be true at the same time, so it's one or the other. This one is they both have to be true. So my point has to be both bigger than -2, greater than -2, and less than 3. So this way, and then since it has to be at the same time, I cut off those external parts. There's two ways to write a compound inequality with an and. This way or this way. So this, especially when people are first learning, this confuses them a little bit. This says x has to be between -2 and 3, which is what it is there. I like this way better, but some people like it's greater than -2 and less than 3. So you have to get used to both ways because they'll ask you to do both. So what I wanted to do was write some graphs here and see if you can figure out what the inequality would be. So for example, this one right here. Is it an and or an or? I hope you noticed up here, and this isn't always the case for ors, but it's always the case for ands. Ands will always have 2 endpoints and you shade in the middle. Ors will have most of the time 2 points and they'll go in opposite directions. So that's a quick ooh, I know this is an and this is an or kind of thing. And I'll hopefully show you an example of the other kind in a minute. So -2 and -4. I like to write it like this. So I'd say -2 and I'd write +4. I know that if I go in that order from -2 to 4, that it's going to be less than signs. I know my x is going to be in the middle. But I see that's a closed circle and that's an open circle, so I know I'm going to have an equal sign on that inequality. So this is telling me that x is between -2 and 4. That's what those less than sign means with x in the middle. And that 4 is included. -2 is not included. That's why they have an open circle there. Okay, now you could also have written it, right? You could also write x is greater than -2 and x is less than or equal to 4. Could write it like that as well. Okay, look at this one. This one's going to be an or. If you do not have the word or in your inequality, it is not right. So make sure you have the word or. If you write it like this, you don't need the word and, but if you write it like this, you have to have the word and. And or are super important because they tell us whether both things have to be true or just one thing has to be true. Or, one or the other. Okay, so open circle, and it's going that way. So x is less than -4, or x is greater than or equal to 2, because there's a closed circle there, so that's why I put the equal sign down. Here we've got an and, so I'm just going to write it this way. We've got 2 closed circles, so I know it's less than or equal to, and everything between -2 and 0, including -2 and 0. This one is an or, so x is less than -2, or x is greater than 2. No equal signs, because they're both open circles. And finally, this little guy right here, x is between 1, including 1, and 5. So that's an and. So we're going to say 1 and 5. So that's how you write them if you see the graph. Now we're going to solve and graph them ourselves. So it's pretty obvious when you get the problem, the and the or. I mean, it says and, or it says or it's a 3-parter, and then it's and. So it's not going to be tricky there. It's an or. So you just have to follow that or down the whole time. Or. So we just solve them separately. So we're going to subtract 4 from both sides. So we get -x is less than or equal to -7. And here is the tricky part that you have to remember. We are about to divide by a negative. When we divide by a -1 to get x alone, that means we have to flip the inequality sign. Remember our last video we explained why that is, because it actually changes the truth value of that statement. So we are going to flip it around. It used to be less than or equal to. We're going to say greater than or equal to. Negative 7 divided by negative 1 is 7. So that's the left part of my or. Now on to this one. Okay, so we've got to add 5 to both sides. We're going to get 2x is less than 12. Divide by 2. X is less than 6. So now we're going to graph it. So here's our number line. So x is 6, we'll separate 6 and 7. 6 and 7. So what they're saying is that it's either less than 6, that way, or greater than or equal to 7, that way. So 6 has a open circle on it going that way because it says less than. 7 has a closed circle on it going this way. And that is our beautiful graph. So this is the solution. This is the graph. Both of those things are needed if it says solve and graph. Solution and graph. Okay, on to this one. Again, it's an or. So we're going to add 7 to both sides. We get 5x is less than 20. We're going to divide both sides by 5. So x is less than 4. That's our first one. Now we're going on to the next one. So this, remember, we have to do them separately. We subtract 3 from both sides. Negative 4x is equal to 8. Then we're going to divide both sides by negative 4. We just divided by a negative. So what do we have to do? We have to flip that. That's negative 2. It used to be greater than. It's now less than. So I would like, this is the one that I said is a little bit different. So here's my, let's see, 5, 4, oh, I'm not going to have room. 3, 2, 1, 0. Negative 1, negative 2, sorry. I was not planning ahead. Okay, so I want you to notice what happens here. This one says less than 4. This one says less than negative 2. But remember, it's an either or. So this one already includes all of these. So I don't actually need this one. So this is the answer of the graph, and this is the solution. So I put it there so you could see it, but if this one is included in everything in that one, you don't need to put anymore. If I say x is less than 4, then anything that's less than negative 2 will already be included. So that's one way that an or doesn't look like two separate things, because one is inside the other one, the set inside a set kind of thing. Okay, let's do some ands. So on an and one, what your goal is to get x alone in the middle. So what you have to do is whatever you do to the middle, you have to do to both sides. You can split them up separately, but I like this better because I feel like it's just quicker because I don't have to do two separate things. So I'm going to subtract 9 from all 3 parts. Obviously, it cancels out in the middle, and I have a 7x. That's 2 negatives. So 9 plus 12 is 21. So negative 9 plus negative 12 is going to be negative 21. 16 plus 9 is going to be negative 25. No, it's not, because that's not negative. My apologies. What do we have there? 7? 7. 7 plus 9 is 16. Okay, there we go. Whatever I do to the middle, I do to both sides. So I'm going to divide by 7, and I'm going to get negative 3 is less than or equal to x is less than or equal to, less than 1. And that is my solution. And then to graph it, I just go negative 3, close circle, 1, open circle, and shade in between, because it's an and. Okay, last one. Do it separately. We're going to add 5 to both sides. 2x is greater than 8. We divide by 2. X is greater than 4. And I have to have the and. Now I'm going to subtract 7 from both sides. So negative 4x is less than negative 32. I'm dividing by a negative, so we have to be really careful here. I'm dividing by a negative. X is greater than 8, so I'm dividing by a negative. So now I've got a 4 and I've got an 8. It says x is greater than 8 and x is greater than 4. But remember, it has to be both things. It's an and. It has to be both greater than 4 and greater than 8. That means over here doesn't work. Well, wait, over here works, but over here doesn't work. Sorry. 5 is greater than 4, but it's not also greater than 8. So all of these numbers in here we have to ignore because we only want the numbers that work for both of them because it says and. So all of these numbers would be greater than 8 and also greater than 4. So that's a little tricky part. So our solution is really just this one. And I should have said that up there too. The solution really is just this one. We don't need that one because that one's included in that one. We don't need this one because they only work together both at the same time right here. A little tricky. We'll practice some more. Okay, good luck. M squared, signing out.